Hello, everyone, and welcome to our video on cardiophysiology. This is going to be our first video, and it's going to be about jugular venous pressure and venous pressure curves. Let's start off by taking a look at this diagram in first aid. This is the Wigger's diagram, and immediately this makes you want to vomit in your mouth because it's so overpopulated and annoying to read. So how are we going to break this down and make this topic easy? So what I want to do is I want to take the right atrial pressure curve, which is the same as the jugular venous pressure curve, and focus on this curve. And then we can attack these curves up here, which is the left ventricle curve and the aorta curve. And if you notice at the bottom here, this is going to be the left atrial curve, which almost exactly mimics the right atrial curve. So let's break this down. So if you look at the right atrial pressure curve over here, you're going to notice there are 3 bumps and 2 descents, or 3 waves and 2 descents. So the way that I like to approach this is get rid of the C wave. This is really confusing, and we're going to learn about this at the end. So when you look at it, only look at AX, VY, because this makes logical sense, and I'll tell you exactly what AX and VY are. So A is for atrial filling, no, atrial contraction, right? And after X, after A comes X, which is atrial relaxation. This makes sense. After the atrium contracts, atrium is going to relax. And V is atrial filling or villing. And Y is emptying of the atrium. So contract, relax, fill, empty. And let's think about what this means in terms of systole and diastole. So when the atria contracts, we are in diastole. And when it relaxes, we are going to start systole somewhere here, right? And the actual start of systole is going to be this C wave over here. So this C wave corresponds to the tricuspid valve coming back and hitting the atrium, generating pressure into the atrium backwards from the right ventricle. So this start of the C wave is going to be the start of systole. And C wave, the peak of the C wave is going to be when the tricuspid valve fully closes and bounces back into the atrium. And also, this is the point at which the pulmonic valve and the aortic valve, if you're looking at the left side of the heart, will open. So let's look at this diagram and correlate these findings to what we see here. So now we could just focus on the left side of the heart. So this is the left atrium, right? So as we said, the A wave is atrial contraction. The X descent is going to be atrial relaxation. The V wave, this little peak here, is going to be atrial filling. And then the Y descent is going to be the atrium leaking. So looking at the aorta now and the left ventricle, we see that C, the C point, is going to be where the ventricle is contracting its hardest, right? So we see it's not the start of systole. The ventricle will contract its hardest sometime into systole, a very short time after systole begins. But the actual start of systole will be right here at the bottom, at the start of the C wave, right? Does that make sense? And then diastole will start somewhere before the V wave. So the V wave is going to be the point between isovolumetric relaxation and rapid ventricular filling, right? And this makes sense because V is filling of the atrium. And then right after the atrium fills, it will be rapid ventricular filling. So the atrium will start leaking. All right, so with this in mind, let's do a practice question. And over here, just before we do the practice question, these are just some pathologies in Boards and Beyond that Dr. Ryan talks about. You can just pause the video and read it. And all of these make sense if you read the explanation and you go back and you listen to the first part of the video. So I'm just going to let you pause and read this, and then we can move on to our practice question. All right. So here it is. You can read this, look at the diagram, and then tell me what you think. All right, let's go over the answer. So basically in this question, the first thing you should notice is that the pathology they're talking about is going to be mitral stenosis. When you see an immigrant in the question stem from a developing country like India, so South Asia, Southeast Asia, or Russia, for example, these countries have a high prevalence of two things that you should think about immediately on step one, and that's tuberculosis and rheumatic fever. And rheumatic fever will usually affect the mitral valve. So you should be thinking of mitral stenosis or mitral regurge. And in this case, it's mitral stenosis because you can hear this diastolic murmur. And then I don't know if a diastolic high frequency sound. So this is referring to the diastolic snap you hear when the mitral valve opens after the pressure builds enough. And so when you look at this graph, you see it's not the right atrium, which is the jugular venous pressure, it's the left atrium. But this looks a little bit different, right? There's an A wave, an X descent, a V wave, a Y descent, but there's no C wave. Why is that? Well, you're going to answer that later. Let's go over which part of this diagram is going to be the correct answer when we hear this high frequency sound, which is the opening snap. So an easy way to answer this, which is the way that I answered it, like when I was doing these questions for step one, is to look at this graph, the left ventricular pressures and the left atrial pressures. So you can see that as the left ventricular pressures build, this is going to be during systole. And at the end of systole, when the pressure falls, you're going to have the beginning of diastole. And right after the beginning of diastole is when we're going to have the opening snap, where the stenotic mitral valve will open and allow the ventricles to fill again. So this will happen. The graphical representation of this happening is when the pressure in the left ventricle will drop below the pressure in the left atrium, because now that the left atrial pressure is higher, blood will be able to leak into the left ventricle. And so this will happen right here. And this is point C. Another way to think about this is that the mitral valve opens when the pressure in the left atrium will be the highest. So it's either here or here. Or in this case, it's either E or C, if you think about it this way. So the pressure in the left atrium will be the highest here. This is when the left atrium will start filling and then leaking into the left ventricle. And so if you guys want to reread this, here's the explanation here. And then the challenge question for you is, why is there no C wave? And the answer for that is right here. It's because the valve is stenotic. So there's no pushback into the left atrium from the mitral valve. And we talked about this with the tricuspid valve, which is where in the right heart system. So if there's no pushback into the left atrium, there's going to be no C wave, because there's going to be no rise in pressure in the left atrium. And that's it, guys. This is a quick explanation of this part of cardiophysiology. Hope it was helpful. Let me know if you have any questions. Email me at smoothbuttermd@gmail.com, and good luck studying.